And now we're going to continue on with our discussion about IP networking, and in this case talking about private IP addresses. What are they? What are they good for? How do we use them? All kinds of good stuff. So private IP addresses came around in the early days of IPv4 when they realized, hey, there's a whole lot of addresses that are needed, and we didn't necessarily chop them up in the classful definitions that they should have been. And so we're going to run out of IPs pretty darn quick. So what they did was they assigned some of the addresses as private, and private basically means, hey, they're not allocated to anybody specifically, and anybody can use them without approval. You don't have to ask anybody. You could just simply use them because, well, they are not routed. They cannot be routed through the public internet. Well, if I can't route this network then across the internet, then there's no possibility for me to be conflicting with somebody else, and therefore I can use them without approval. Great. So it's an IP address that anybody can use. They just can't route it. Well, that makes life simple for us. For IPv4, this is all governed under RFC 1918. If you've ever had a chance to glance through these RFCs, some of them are quite interesting. RFC 1918 defines some public IPv4 addresses. Again, these are addresses that anybody can use, and they're just not routed across the internet. Therefore, there's never going to be any possible conflicts. So it defines three ranges. Basically, the 10 dot range. I always look at this, remember, with the /8. So this gives me a possible 16.7 million different IP ranges, or different million IP addresses, which I can then subnet and break apart as I might possibly need. Surprise, surprise, this is the one most commonly favored by network admins in most organizations. Because, hey, 10, that's a small number, it's easy to work with, and I have lots and lots of room to grow. Next range, 172.16 through 172.31, or if you look at the CIDR notation, it is a /12. This gives me a little over 1 million addresses. Again, I can break these up into smaller networks. It gives me basically 16 contiguous Class B networks, which I can then break up into multiple Class C networks. So 16 Class Bs, maybe if I have 16 different locations, I'll start with the 172.16 in one, and then 17 and so on. And then each floor or each department inside of that, I can then break up into a Class C. And then lastly, 192.168.00 through 192.168.255.255. This gives me about 65,000 addresses, or 256 contiguous Class C networks. Well, Class C networks are probably the easiest things for us to manage, so that's quite commonly used. Again, I always try to remember these. Well, I've got a /8, I've got a /12, and I've got a /16. 8, 12, 16, very easy for me to follow and remember. The 192.168 range oftentimes is used in home networks. In fact, if you're watching this from home and you run an IP config, chances are you're running something in the 192.168 range. If you're running it from a business environment, you're running in the 10 range. And then if the 172s, for the most part, from what I've seen, have been kind of forgotten. Maybe some network equipment has been assigned to it, but that's about it. All right, so again, great thing. Anybody can use these networks. Anywhere within the enterprise, you can route internal to your organization. However, you cannot route outside of your organization unless it's a VPN or a WAN link between your organization and somebody else who recognizes these IPv4 addresses. The only thing you have to worry about in this case is if you expand your organization, you may conflict with other organizations. If I'm using 10.0.0.0//24 and I merge with another organization that is using 10.0.0.0/24, then we may have a conflicting IP range. but that's a special case that hopefully you don't have to deal with too much. All right, so those are the private IPv4 addresses. There are actually a few more that are used for special cases, but these are the main ones that you're going to end up using in the world. Otherwise, in IPv6, there is similar ideas with some private IP ranges. First off, we'll just start off with these guys, unspecified and loopback. Not too special about that. Just basically you can't use them out on the internet, but anybody else can. Otherwise, there's two very special networks here. There's a unique local and a link local. The unique local is essentially the same as RFC 1918. These are your local unique IP ranges. So this is the equivalent of the 10.000/8 right here in the unique local. As you can see, it's a /7, which means you can do all kinds of crazy things with networking here, subnetting and so on, making all kinds of highly complex networks with it. It has been suggested, due to the plethora of IPv6 addresses, not to use the unique local addresses. You just don't need to. Just call up your ISP and say, I need more IPs. If the ISP gives you a problem, then that's going to be really surprising. So don't use the unique locals, maybe if you have a lab or some very special case, but in general network design, you don't need to worry about it. So just don't use them. The last one here is what's called the link local. You may have seen on a system that you can try to connect to the internet, and you look at the address and it's a 169.254.something.something network. And this is an IPv4 link local address. Under IPv4, that means that it tried to get an IP address from DHCP. It couldn't, so it fell back and self-assigned an IP address to itself, a link local address that only worked locally. It only worked on the local link. The idea being, if your DHCP server fails, two computers on the same network can still talk to each other. Well, that didn't work out too well under IPv4, but it works out a whole lot better under IPv6. Link local address for IPv6. Basically, whenever you fire up a machine running IPv6, you may end up with both a global unique address and a link local. The link local is used just to access all the local resources. Hey, if it's on my local network, such as my router, I'm going to use that local address. If it's outside of my network, say on the internet, I'm going to use the global address. This guy, for the most part, you define the prefix in your organization. I want to use this prefix on this network or this prefix on that network, or just in my entire organization, I want to use this prefix. The rest are automatically assigned by the system. So, private IPv6 addresses, for the most part, you'll use a link local. You don't really have to configure a whole lot other than just configuring your router with a correct link local address. Otherwise, most everything else takes care of itself. IPv4, well, there's a lot of address ranges to look for. If you think you're going to be merging with somebody, you may want to see what kind of IP address ranges they're using to make sure that there's no conflicts. Otherwise, choose a large section and start segmenting your network as appropriate.